Hey, alright, my name's Darian, and right now I'm going to do problem 4.8.19 out of the book. We need to graph this function right here. So the first thing I'm going to do is find the derivative of this function, which is right here. F prime of x equals 5 over 3 times x minus 2 to the 2/3 power. Now, if we find the critical points, which is actually at x equals 2, we can figure out from x equals 2 what the derivative is at points above it and below it to tell us what this critical point does. Alright, if you plug in x equals 10 to the derivative, it will be, you'll have 10 minus 2, which is 8. 8 squared 64. The cube root of that is positive, times 5 over 3. It's going to be positive. So positive on the right side of x equals 2, and then on the left side of x equals 2, let's do x equals 0. That seems easy enough. If we do x equals 0, we'll end up with negative 2. Negative 2 squared is 4. The cube root of 4 is a positive number. And then times 5 over 3, that's also a positive number. So from here we have, it's positive on the left side, positive on the right side. That means that this is not, it's going to change concavity, essentially. Which means that our graph is going to look something like this. But we can be a little bit more precise than that. We can figure out where its y-intercept is. So to do that, we need to find where f of x is equal to 0. And you can do that by writing out this 0 equals 1 plus x minus 2 to the 5/3 power. Alright? Now, once you do that, you can subtract 1 from both sides. You'll have x minus 2 to the 5/3 power equals negative 1. Okay, since it's to an odd power, using what I know from any kind of algebra, you guys can all reason this out too. 1 to any power is going to be 1. Negative 1 to any odd numbered power is going to be negative 1. And to any even numbered power is going to be 1. So since we need this in here to equal negative 1, it's going to be set to an odd power, 5 over 3. All we need to do is find a value for x where inside of these parentheses it will equal negative 1. And that would be x equals 3. So that means that x equals 3, 1, 2, 3. The graph is going to intersect right there. Now, that is actually the x-intercept, I'm sorry. The y-intercept would be when we set x equal to 0. So, when x is 0, you have 1 plus negative 2 to the 5/3 power. Okay? 2 to the 5th would be 2 times 2. 4 times 2 is 8. Times 2 again is 16. Times 2 again, 32. Find the cube root of 32 plus 1. And that would be, it would give you negative 32. So you find the cube root of negative 32, which is going to be a negative number, plus 1. It's going to be on the negative end of this y-axis, which means that your graph is going to look something like this. The reason that I have this right here is because I know that this is a point of inflection, which we found right down here, x equals 2. I'm sorry, this x-intercept thing that I did was incorrect. Please ignore that. Actually, based on what they showed us in this chapter, the only thing that you needed to know was to find the point of inflection. We'll find critical points, which was at x equals 2. Alright? And that critical point, that's the critical point. And since the slope is going to be increasing on both ends, we find that it's going to be like this, not like that, like a parabola. Now, there's one more thing we could do to make this more exact. We could find exactly where this point of inflection is. It is at 2, 1. And you find that by, over here, plugging in the value 2 right here. So if you plug in 2, it will be 2 minus 2, which is 0. 1 plus 0 is 1, which means that the point of inflection happens at 2, 1. That is your graph. These arrows mean that it goes on for infinity. This video was helpful in graphing functions such as this.